All right, so last section here in chapter 5, we have the 5-3 notes. This is our segue into linear functions. So, kind of going off of what we just did in the previous couple sections there, where we were determining whether something was a function or not. Now we're going to be getting into linear graphs, linear functions, linear equations. They're all kind of the same thing. So before we do that, we want to know which of these values is not in the domain of the function. Now we don't need to know what the function is, because remember, we can still determine what the domain is. And remember, domain is talking about your x values. Okay, so the domain is your x values. So what we want to do is we want to look at these x values and see which of these four x values are not part of the domain. So first up is -2. Well, if I look at -2 right here, is this covered? Let's just try that one again real quick. We want to know, is this covered in the domain? And that one might be a little confusing because we have the open circles there, so some people might be thinking, I don't know, maybe it is, maybe it isn't, I don't know. So let's look at the next one then. B is -1, so if I look at -1 right here, does the graph hit that? And yeah, it hits it right there. Next one, 0. So right here is 0. Does the graph hit, do we have an x value that's defined here? And yes, we do, again, right here. And the last one is at 2 for the x value of 2. So this is where I'll compare 2 and -2. And we see what the difference is here. And at 2, we have this filled in circle right here. So 2 is part of the domain, which means -2 is our answer, because we want to know which of these is not part of the domain. Okay, so let me erase this line here, and I'll explain a little bit why this is not. So at -2, you can see that we had an open circle here and an open circle here. Open circles are not included, so this did not have any value that was included at -2. We had some values less than -2 up here and greater than -2 here, but there are no values that were equal to -2. All right, so -2 is the answer because we were asked which one is not in the domain. Okay, so graphing functions. I don't know how much of this you actually do in whatever class you have in 8th grade, pre-algebra, or whatever it is, but we'll get into a couple different ways of graphing linear functions, but we always start out with a table. Okay, so we choose the x values, we choose what values we want to plug in. Okay, we're picking our input, plug it into the function, and then we will get our output, or our, the range and the y values. They're all the same thing. So typically what we do here is we start, I'm going to put 0 in the middle, -2, -1, 1, and 2. So this is typically how we do our table. Sometimes we'll only have 3 values, sometimes it'll be a little bit more. You can use whatever values you want to here, but you want to make sure that they're going to stay on the graph. Okay, so we don't want to use like 10. Okay, because if we look at our graph here, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It'll be right at the edge. And if we plot the y value, it might not fit on here. So, yeah, we want to use values that are going to land on the graph. All right, so let's plug -2 in. So what we're doing here is we're going to do negative, and then x is -2, and then we have -1. So we're going to plug in -2. So what do I get here? Well, these are a double negative, so that's a +2. -1 is 1. So let's plug in -1 now. So I have a negative, I'm plugging it into this function right here. So I have a negative, and then x is -1, and then I got a -1. So this is, double negative is a positive, so 1 minus 1 is 0. Next is 0. Let's plug 0 in. So I have negative, and then x is 0. -1. Well, -0 is the same thing as +0 because 0 doesn't have a positive or negative. So I have 0 minus 1, which is -1. All right, let's keep going here. Plug 1 into our function. So I have negative, x is 1 minus 1, and this gives us -2. Okay, at some point you'll recognize the pattern that's in the table. So like here we go from 1 to 0 is -1, and then -1 is the -1, -1 is the -2. Okay, so if we subtract 1 again, we should get a -3. Or we can just plug that in there. We say minus, and then I'm plugging 2 in now, so 2, and then minus 1. So negative 2 minus 1 is negative 3. So basically what we just did here was we created a set of ordered pairs. So the x value is 2, y value is 1. So starting at the middle, we plotted points before. We did that before Christmas. So starting at negative 2, 1 means from the middle, I'm going to go to the left 2 and up 1. Negative 1, 0 means I'm going to the left 1 and then up 0 or down 0, which means we're not moving up or down at all. The next point is 0, negative 1 means I'm not going left or right, but I'm just going down 1. And this point has a special name that we'll talk about later on. Whenever the x value is 0, that point has a special name. Next is the point 1, negative 2, so we go to the right 1, down 2. And the last one, 2, negative 3, means from the center we go, or from the origin we go to the right 2, and then down 3. Okay, so now remember, this is a linear function, so it should look like a straight line when we graph this. So if you're graphing your line, and it kind of like, if you're graphing the line and it does something like this, that means you plotted one of your points wrong, because this should be a straight line. There shouldn't be any like bumps or anything like that on it. It should just be a straight line. Okay, so our straight line here, and those of you that are doing your notes on your Chromebook may have a little bit of a challenge with this, as I do, trying to get the line to look straight, but again, we're just going to do the best we can. If the program you're using, DocHubs or Cami, if it has a line tool, you can just use the line tool. So like if I take my line tool here like this, I can create a straight line and make it go through my points, or kind of make it look like it goes through the points at least. Mine doesn't really there, but one thing that you do need to make sure you have is you need to make sure that you have arrows on the ends of both of your lines, because this line does continue on forever. We're just cutting it off at our graph. So make sure you have arrows indicating that the line does continue on in both directions. All right, next one. Now we got a multiple choice. Company estimates its total monthly expenses using the equation y equals 4,000x plus 4,000. Which of these graphs shows this relationship? So remember, this is your zero term. Okay, and the zero term means that wherever we are on the when the x-axis is 0, our y-coordinate should be 4,000. So if we look at this here, just knowing that information, we can see this starts at 0. This one starts at 0, so those two are out. We need one that starts at 4,000. This one's out, that starts at 0. And then this one right here, this starts at 8, which we're told right here that this is in thousands. So this one starts at 8,000, so that one is out. And this one right here starts at 4, but again, we're told this is in thousands, so that one starts at 4,000. This number right here, we're just going to verify we did it correctly. This number is the increase. So we can see here that after 1 month, it increased to 8, which is 8,000. So that went up 4,000. And at 2, it was at 12, so that's up another 4,000, and so on and so on. So we know that C is our correct answer. Next, number 3. John is selling sandwiches for a fundraiser, and the sandwiches cost $6 each. And there is a delivery fee of $2 per order, not per sandwich, but per order. So if he orders 1 sandwich, there's a $2 fee. If he orders 20 sandwiches, there's a $2 fee, regardless of how many sandwiches they order. Okay, so number of sandwiches. Now, when we did a table earlier, we started at -2 or -1 or whatever. We're talking about the number of sandwiches. We don't want to start at any negative numbers, and we don't even want to start at 0 sandwiches, because we want to order some sandwiches. So we're going to start this at 1, and we're going to do 1, 2, 3, and 4. Now, if we're writing the equation, we have blank n plus blank is our cost. And remember, this is the 0 term. Now, this is a problem that if we look at this formula in the context, will not really make sense, because the 0 term, if we plug 0 in here, we're going to end up with 2. but that's basically saying that if we don't order any sandwiches, we're still going to owe $2. So this one doesn't really make sense. This one is really only defined for the values of n that are greater than 0. So, if somebody ordered one sandwich or whatever. But then this number right here is the amount of increase, so that's going to go up $6 because it's $6 per sandwich. Okay, so if they order one sandwich, we have $6 for the sandwich and then $2 for the delivery fee. That will be a total of $8. If they order two sandwiches, $6 each means that it'll be $12, and then plus the $2 delivery fee would make this $14. And then for 3 sandwiches, 3 times 6 is 18, plus 2 gives us 20. So look at what's happening here. 8 plus 6 is 14. 14 plus 6 is 20, so I know this one will be 26. 4 times 6 gives us $24 for the sandwiches, $2 for the order for the delivery fee, so that's 26. So that's what your final answer should look like there for number 3. All right, we got 2 more. We're going to go back to another table. This one, the table is filled in for you, and we want to know which of these will be our correct answer. Now, Sam is doing crunches, and he's basically recording this starting at 0 days, and then 5 days, 10 days, and 15 days. So that doesn't really help us in our X column or the input column, because they all have the same values. All right, so Sam could do only 5 crunches before he began. So that means at 0. Okay, at 0 before he began, he could do 5 crunches. So looking at A has our 0, 5. B has the 0, 5. C has a 0, 7, so C is out. Let's get rid of C. And D has 0, 5. All right, so let's keep going here, and we'll see. So now that tells us that our blank n plus blank, if after, at the start of it at 0 days, he could do 5 crunches. So we got to figure out what this number is here now. At the end of each day of training, he was able to do 2 more crunches than the day before. So that's our rate of change, which is our slope, which is 2. Okay, these are all terms that we'll get into later on, but that's the number right here that it's increasing each day. Okay? So what we want to do now is we want to see, well, which of these will be able to answer this question. All right, so on day 1, he could do 2 times 1 would be 2, plus 5 would be 7. Okay, but our table just goes in increments of 5. Okay, so let's do 5. 2 times 5 is 10, plus 5 is 15. Okay, if I plug 5 in there, 2 times 5 is 10, plus 5 is 15. So this one told me that when I plugged 5 in, I should get 10. Well, we just did that right here, and we got 15, so we know that one's out. B, we have our 515 there, so B is still a good one. And then D, we got 527, so 27, D is out. 5 should have given us 15. So now we know our correct answer is B. Okay, and you could check it for the other ones to make sure, like let's try 15. So if I do 15 times the number of days, 2 times the number of days, which is 15, plus 5, well 2 times 15 is 30, plus 5 gives me 35, and it works. Okay, so we know that that table is correct. All right, last one here, number 5, an online booking agency. This is very, very similar to the Hoagie one. If you've ever ordered tickets online at like Ticketmaster or StubHub or anything like that, there's a cost per each ticket, and then they have like their extra fees, their processing fee or whatever. So if this is described here as 20t plus 4, which of these statements is true? Now remember, this 4 represents your cost regardless of how many tickets you order. Okay? The other thing is this number here is our rate of increase, which tells us if we ordered like 3 tickets, we would have 3 times 20 and then plus 4. So 20 is the cost per ticket. Okay? So each ticket costs $20 and the ticketing fee is $4. The correct answer there is C. Okay, so again, we're kind of bridging the gap here between the relations and functions until what we get into in chapter 6, which will be starting with linear equations, linear functions, writing them, graphing them, writing different forms of linear functions and everything. That's what we're going to be doing in chapter 6. So yeah, like always, if you have questions, send me an email or a private comment, and I will get back to you.